Oh, really?
Yes, so I thought I would kind of mention that to you.
Okay, because I watched them even though, like, after obviously I can't make all of them. Yesterday my sister had an orchestra concert, so I was like, so, okay. So we can put that on like Thursdays, and that would count?
Yeah, either Thursday or Tuesday, either way. I mean, as long as you just say you watched the video, you can get credit for it. But I think we still need to at least meet one time to be able to go over our group project and any questions.
I agree. Okay, that's
So,
good
I
because
mean,
I didn't go, but I watched half of it so far, so.
yeah.
Okay.
So how he phrased the example question, we're going through our final project, designing a study. He said, like, his example question was, is there a difference in the price of books at the bookstore compared to those available online? And we're not looking for a difference. We're just going to try and say we're trying to determine what color, or do we have to have a specific color? Do we have to have a hypothesis of what color we think we will see more? Do we think that, you know what? Not the same, right? It would be the null hypothesis is either the same or they are not the same, because isn't that like an ANOVA testing or something?
ANOVA is like 3 or more.
Okay.
So, like,
and colors are the one. Yeah, so we can just kind of say, have a hypothesis, probably. Do you have what color, or would, I don't know, I have a hard time sometimes phrasing these questions. It's about M&Ms.
I don't, do you have a specific color?
Well, I'm just trying to think, the question should be like, term colors or equal cups or something.
Say that again, it kind of chopped up.
I'm so tired. Guys, I'm in a meeting. Today. Is there I don't know, difference in the number? I don't remember how I phrased it just a minute ago.
So, tell me again, because I think you kind of chopped up with the.
Okay, probably because my boys walked in the door and were making noise. I'll try it again. Okay. So, on the M&Ms, if we take 1 cup of M&Ms, we want to see amounts of color, like if all colors are equal, or what the difference in colors are within the 1 scoop of M&Ms. Colors there are in
the difference, but maybe we should like pick a color that we think we're going to see more, probably to make it easier on us. Like, what was that?
I said I have no idea which color I think. I guess I can look at my M&M bowl and see how many I think I see the most of.
Really? I have like the little baby M&Ms, so I'll just.
And I guess I could ask you, do you want to do the baby M&Ms and do 50, the 1 cup of a bowl M&M?
Oh, it doesn't matter. I can go to a Winco here or get more bags of this. So, like, whatever's easiest for you, I can do too.
Just do the little mini bag option. Like how many are in a little miniature bag? For like our, if we're going to do like the little bag of M&Ms, I don't know how many ounces are in that, or if we wanted to just go buy in bulk and measure it by the cup. So the way we're measuring the M&Ms, whether we're going to do it by individual packets and have you buy 15 and me buy 15, or Woke and then have me do 15 cups worth and you do 15 cups worth?
I think the little packets.
The packets?
Yeah, just because like if we do it in the packets, we don't have to like predetermine how like much we need. And so we can just say
I like the packet idea because then we'll see if they're the ones
yeah.
that are coming in to try and make sure they're equal.
Yeah.
Okay.
So we're not like measuring out how much it's what the packages already give us from
Right.
the company.
Okay, and you're okay to buy 15 packages and do that?
Yeah. Yeah, my husband's like,
You seem to like M&Ms, so we're good.
yeah. He loves M&Ms, so.
Okay. So now the question, okay, we want to see if there is for a difference then, or we're just, because the difference is saying that they're not all equal, but we're trying to find out if there is a difference in the, and I don't even know how to phrase it, the number of M&Ms per color, or.
So we can go two different ways. We can see if there's equal amounts of M&Ms in each packet, or we can do, is there a dominating color in 30 packets of M&Ms?
I don't know. I kind of like the each package one, seeing if the amounts are equal in each package.
Okay. So we would just basically have to count if there's like 8 in this one. Is there going to be 8 in all of them, or is there going to be 9 in all of them, or they're just going to, or?
Well, is our hypothesis going to be that they are equal or that there's a difference? And then I guess when you're analyzing it, you're looking per packet, what was in, comparing the packets and coming up with the overall mean of all of them versus the individual packet.
I would say they're probably unequal. I don't know. That's just my.
Okay, yeah, so we don't think they're equal.
But do you think they're equal?
I think they're equal, but it would be interesting to see how it turns out, right? To see how it really is spread across, and if they have even if there's between each bag, right?
Mhm.
So, okay, so now we're gonna look for maybe if there's equal amounts of M&Ms in each package. So how do we phrase that?
So we can say we are trying to determine if there are equal amounts of M&M candies in 30 individual packets, or fun size or something. Does that make sense? Or is that
size? I don't have an individual packet with me. Do you know what are size on the M&M packet you just had?
This was are we doing the big ones like this, or like the little like the handout ones, like for Halloween?
Yeah, and does it say like on the actual individual? Oh, so you're doing the mini M&Ms. So do you want to do mini M&Ms or regular M&Ms?
Probably just regular. So do we want to do it like this size, or like the little ones that we like can do for Halloween?
Little ones for Halloween, but I don't know what size they are. I have to go try and see. It should say on their package.
Maybe I can look it up. I probably can.
Equal amounts of colored M&Ms. Or equal amounts of M&M.
That looks like it's. Wait, hold on. I guess it's not as easy as I thought it was to look it up.
Might be able to go upstairs. I get candy from us.
Oh, wait, here we go. I think this is it. It looks like
Am I
40 grams.
good?
What was that? I think they're 40 grams.
So I can find out, I guess, what size of package it is and write that into the question.
Okay. So I think they're 40 grams if that helps. Okay.
I guess it lost. So I was working on the question. I wanted to try and see if we can get the question down. Or it says, we are trying to determine if there are equal amounts for each color of M&M candy within a package. Does that sound right? I'm trying to phrase it to where it's showing that we are looking at each color of M&M within a package, but
Okay.
for each color, if you can think of a better way to word it, let me know.
So tell me what you have again and I'll write it down.
Okay, we are trying to determine if there are equal amounts no, sorry, let me read it the way I have it. Okay, we are trying to determine if there are equal amounts for each color of M&M candy within a package. And I'll probably write down the size of the package within a such and such size package.
I think they're 40 grams.
Color of M&M candy within a package, a 40
Within a 40-gram package.
people can understand exactly what we're looking at. So our hypothesis within that would be that they're equal, and the alternative hypothesis is that they are not equal, right?
Yeah. I don't think they are.
But the null is always saying that it is equal, right?
Mm-hmm. So we would just say, so it'd be
The alternate hypothesis.
and then the alternate would be like equal with the slash through it.
Yeah, it would be the not equal study.
Yeah.
Hypothesis things. The population we're studying would say packages or 40-gram packages of M&Ms. Population would be.
What was that?
The next
population
question talks about studying, and I think it's just the 40-gram package of M&Ms. That's our, right?
Yeah, I think
it's
we
not
can
all.
Say 30 of them.
So I'd put 40-gram packages of M&Ms as our population. What is your experimental unit? Would be a sample M&Ms, because we're doing a sample of it. He had, like, for his example, when they were trying to do the line, he had the BYU Idaho students were his population. A 40-gram package of M&Ms, but our experimental unit is going to be a sample of packages of M&Ms, don't you think?
Yeah.
Away.
What is your response variable?
What are you collecting? It's your data. So I'm reaching would our response variable be the color? What are you collecting? It's your data. In a package, or the numbers and colors that we're mainly doing. It looks like an unresponse variable that you run all the tests on. And the response variable is supposed to be our data. So is the response variable the number of M&Ms or the color of M&Ms?
Probably.
Are we going to be doing like a pie chart then? You know, to show, because we're looking at it more distribution, right?
What was that last part?
I'm trying to figure out, like, looking forward, you know, if you're doing a pie chart, you're kind of showing what percentage of the whole it was.
Yeah.
But
I think that would be easy for colors anyways.
So our variable is going to be color, because we're wondering how many colors. That's what we're looking for, is the color within each package.
Mm-hmm.
I'm just going to put that color of M&Ms within each package.
That sounds good.
Is your response variable quantitative or categorical? I believe it's categorical.
Yep.
But we're also using numbers to figure that out, right? But it's...
No, I think it's more colors. Because, I mean, we'd want to do like, because we have to do 30 to get a good
right.
sample size. But we're really looking for how many, like what the colors are in each.
Okay.
So would it be F?
Sorry, would what be what?
Would number 6 be F?
Oh, 6.
Oh, sorry.
Categorical population. Just doing one group of M&Ms, and we're seeing what the difference is within them. Let me see. Where was my review notes for the test? He had some good notes in the last video. Which text was? And yes, I'm on my second binder. Okay, I need to do better with my notes. I've got all my texts and materials. I got really organized before my class, which was good. Okay. So we were doing categorical test of one proportion. One group, sigma unknown. We don't know the standard deviation yet. So this is one sample p-test. But that's only with quantitative. We're going to be testing proportions. So yeah, that's yeah, categorical test for one proportion. Yes, that's what I think we're doing.
Okay.
Okay, what are your null hypothesis and alternative hypothesis?
So.
And I don't remember on the categorical, that was one we just did, right? The proportions and categoricals.
Yeah.
Let's see how
We
they
need
did
to
there.
try and look in more alternative.
Let's see. Because I kind of start getting confused sometimes when they do like the mu of D or the...
Yeah.
I have to go back and remind myself what they're... I mean, I know, yes, the hypothesis is that they're equal or they're not equal, but I don't know if they do much hypothesis and proportions. Just 1 minute. Lydia, can you get the phone, please? My kids are all home from school today.
So
it's
this one
harder
would
to do
be
that.
like HO equals E. For proportion.
Yeah, I'm trying to find one. I'm looking through my work trying to find one for the quantitative where they've actually stated a hypothesis, just to see how they... it was more about showing it with graphs. I don't remember a lot of the...
I think it's P equals P 0 or O, and then P doesn't equal.
Okay. That sounds right. Is it the P hat or the P?
Looks like it's just the P.
Where are you looking to find that?
I
Just
looked up
off the top of my head.
just hypothesis testing for proportion.
Okay. And you looked it on Google or?
Yeah, but I can probably go
Okay.
find it in the lesson plan.
Yeah, I'm trying to. You'd think it would be pretty easy to find.
So it says sample in section 3.
Oh, here it is. I've got one on lesson 17 under 4.1 step 4. It has the HO colon and then P is equal to an amount, and then the HA colon and P is not equal to an amount. And we're going to put 0 as a difference, or not equal to 0 as a difference, or sorry, the number that we have is going to be the true proportion of people who can taste PTC is 0.72%. So we're having to come up with a percentage on what we think it's going to be.
I almost think maybe it could be like
But yeah, we're still going to have the hypothesis test, I think, because we're doing the probability, right? Where you do the NP is greater or equal to 10, or the N of 1 minus P is greater or equal to 10 to satisfy our tests. I don't know. Just trying to make sure that I have it set up right, and trying to apply it makes me have to learn it in a different way.
Yeah.
Let's see if we have any other.
Is it possible to put like a color or something? Or I don't know if that's allowed.
Yeah, I mean, we could hypothesize that there's a color rather than like doing. Yeah, I'm just trying to look at like the hypothesis question. Like he had when he was doing his thing on the bookstore, he had the HO of mu of D is equal to 0, and the HA of the mu of D is not equal to 0, but that's because he did quantitative data. And it was, I think with the categorical data, we kind of have to do the HO and we have the P, right? That is our test statistic.
Mm-hmm.
So the probability or the proportion is, so if there's how many colors in an M&M package?
6.
So there's 6 colors, then that would be, do you just divide 6 by 100% and then see if the P is equal to that percent for each one of them? Makes sense. Like if there's 6 colors, possibility, you know, you're trying to say that each one is going to be portion 6. So you're kind of trying to say that about roughly 16.6% is going to be.
Yeah.
For each one, would we kind of say, would that be what we used for our proportion there? We're saying that to, like, I don't know if you round up, round down, round up 17% proportion, or it's not equal to 17%. I don't know.
We're trying to say like there are all 6 colors in each bag by doing that.
There should be some of each color represented in a bag. I can't imagine they wouldn't have at least one of each color in a bag.
Mm-hmm. Okay.
So if you're trying to say that, you know, you're 1 out of, you know, 100 divided by 6 is basically 16.666%. So, you know, if you wanted to see if they're all equal, you would say the proportion, would you say the proportion was 16 or 17% or?
Yeah. So we're trying to figure out like if, okay, so we're trying to see if the equal amounts for each color. So we think there are equal amounts of each color in each bag?
We don't think that there are going to be equal amounts.
Okay. So would our alternative hypothesis be like the opposite of what we?
Like if you're assuming, we don't assume that it's the case, but this usually is always equals, right? So you have to have something you're assuming it's going to equal. And so
are we not doing P equals? Okay, so we're doing P equals 0.17 right now, right?
well, that's what I would guess if you're looking at the 6 colors, and the proportion, if you're going to be equal, is going to have to be approximately 17% per color.
Okay. Because I was thinking we were doing HA right now, so that's why I'm confused. All right, so now I understand.
So the HA is that P is equal to 0.17 if they're all going to be equal. If they're not going to be equal, then it's not equal to 0.17.
Yeah, okay, that makes sense now.
And I guess I'm just looking at that, you know, if we're trying to say they're equal and there's 6 colors supposed to be in a bag, then we'd kind of look at each of those colors and run the data, and then, you know, the proportion is supposed to be if they're equal that. So basically, if it's not equal to that, then they're not equal, and you would fail to reject that they were equal.
Yeah.
Or reject that they were equal. Anyways.
No, that makes sense. All
yeah.
right.
So I think that's our hypothesis.
I think so too.
Okay, there. And he'll check this. He'll give us a, you know, he'll look over it and let us know, you know, because he has to approve it. But which sampling method will your group use? Systematic sample, cluster sample. We're just going to grab a bag. Random bag.
Random sample. I guess it could be cluster because we're looking at M&Ms.
Well, you're grabbing a bag from Nevada, and I'm grabbing a bag from Oregon, so that works.
Okay. Yeah.
Simple. Yeah. Okay, so it has to be some sort of a sampling method. Remind me, the systematic is you go every nth number. A cluster is you take, yeah, it's probably going to be a cluster because we're taking one cluster from where you're at, one cluster where I'm at, and we're looking at all of them.
Yeah.
Or wait, unless the bag has more than 15 bags or less than 15 bags, then we're going to have to decide which bag. We're going to have to
maybe we can tell each other to pick. Like, if you have one, like, we can get the exact same bag. Maybe.
Isn't the stratified one where you have groups and then you choose out of those groups? You don't do all of them, because the cluster is if you do 2 different clusters, you do everyone within the cluster. But the stratified is where you have groups, but you only choose, you know, certain amounts within the group. I have to go back. I think stratified is the one I was thinking.
It says it's in my syndicate. I'm gonna look it up right now.
Okay. Because I know there was 2 different ways of doing groups. One was the cluster, which I don't think, because within the cluster you have to do everyone within that group. So if you get a bag of M&Ms and there's not 15, you have to go get another bag. I don't see that we'll get an equal amount of 15 bags in any one bag that we choose. So therefore, we kind of have to choose within those bags, find a way to choose, you know, whether it's every second bag you pull out, or
So
I don't know.
Simple random is just there's a list of items in the population and they all are accessible, so we can maybe do that one. Systematic is every kth item, I guess. Cluster is taking all items in one or more randomly selected clusters or blocks. Stratified is so it's like when the items to be sampled are organized in groups of homogeneous items called strata. So that's basically the one where it's like group 1 is 1,000 to 2,000, group 2 is 2,000 to 3,000.
Oh, okay. So maybe just a simple random sample is the one we're doing.
Yeah, and then there's convenient sample, but
that's not good.
So I think it might just be simple.
Okay, so that's the method we're going to use. But does it have, that is one of our options, sampling methods? Simple random sample? And how do we assure that it's going to be a simple random sample? It's just you grab out of a store?
Yeah.
So one bag there.
Get little.
Yeah, it does help that we're in 2 different locations.
See if they're shipped differently or something.
So why not? I think that works. Next question. Okay. Okay, please review the different data collection methods. Please note that true random samples can be difficult and another method may be easier to obtain. If you choose random sample, please describe in detail how you will the experimental units are selected randomly. Note, haphazard data collection is not the same as random.
We're both doing 15, and we're both from different states, so that's pretty random. And
okay, I know that when he was saying it, that he was going to randomly select or systematic or randomly picking one. I don't know. He said at least 30 for the central theorem, which is some central limit theorem, which is what we're doing. And he said they could do like every 10th book or every 6th book. I guess we could do, if you're going to get a package, you could do every other package that you grab out, right? If you have a package, do 2 piles.
Yeah.
But then that might mean you need to buy more than 15 packages. But I guess we'll just touch base on this one because I don't know how many packages are within an M&M bag. If there's more than 15, it's great because we can just, mix them up around and grab them out, randomly select them. So
yeah, but I mean, if there are 15 in each one, I think it's pretty random because I think like the different states. Because I mean, if you went to the same store and you got 2 bags of 15, then it's not very random, I guess. I don't know.
Okay. And it says, describe in specific detail how your group will collect data using the sampling method stated in question in step 8. Also, what sample sizes are you planning to obtain per population? This section should have enough detail that a reasonably intelligent person that has never taken a statistics course could replicate your study. So we're going to do simple random sample. And we are going to each go buy a bag in different states and then select 15. And we'll have to look at how we need to select that. Probably, I don't know. The way he put it, he says, I will do systematic sampling by starting at book 5 and then select every 5th book until I get a total of 30 books. But
so that's simple random sampling?
That's the systematic sampling.
Okay,
is what he put.
Okay.
Yeah, they did systematic sampling in theirs, but we're going to be doing the simple random sample. So we're going to do simple random sample and then change that one. By purchasing bags of M&M packages and choosing 15 bags.
We both have to submit this part.
So I can type it up and then send the file to you via email, probably.
Oh, okay.
I will do a simple random sample by purchasing bags of M packages. Or we will do, sorry, we will. We will do a simple random sample by each purchasing bags of M packages and choosing 15 individual bags. Okay, for a total of 30 bags. Half of each bag will come from different states. Let's see. Two states will be represented within the 30 bags of M&Ms. Okay, please review the requirements in the text for your chosen method from step 6 and discuss why your study is in alignment with the requirements. So the requirements for the quantitative proportions test is that the n times the p is greater or equal to 10, and the n of 1 minus p is greater or equal to 10, right? Because it's a hypothesis test, and we're trying to make sure that the number of samples times the proportion is greater than or equal to 10. The number we're going to have is 30, and we're saying that the p is 0.17, right?
Mm-hmm.
So the 30 times 0.17 is going to be greater than 10, I think. I think those are the requirements we have to write, right? Is the I'm trying to look where the other requirements are. There, it has to be approximately normal. Okay. We have to have the condition to have if you're looking at it's lesson 17, 4.1 step 4. It kind of shows the requirements of that, and then it says the sample size, which we have is large enough for the central limit, and our p is approximately normal. So how do we assume? Do we have to? Our p is approximately normal. Is that where you do like the QQ plots? Or?
Let me see.
Notice that the requirements are set aside for the PTC data because that says we can use a procedure that mimics the test for a single mean with sigma known. Hypothesis test. That's for a single proportion.
So it's NP is greater or equal to 10, or n parenthesis or n times 1 minus p greater or equal to 10.
Do we have to do a QQ plot for normality, or does that only go with quantitative?
I'm not sure. It doesn't look like.
Okay, because we're saying our number is 30. Oh, our probability of saying 17%, if we do the number 30 times by the 0.17, that only equals 5.1, so it's not greater than 10 there.
So should we do 2? So for like every, I don't know.
Let me just try this here. 1 minus 0.17 equals times by 30. Yeah, well, that one works though. Okay, let me try. Maybe I did the wrong n. Our n is 30, right? Okay. So 30 times by 0.17 equals 5.1. Yeah, we're about half there. But on the other one, where you're taking the 30 or the 1 minus the 0.17 equals times by 30 is, wait, okay, I need to totally clear that out. Okay. 1 minus 1 minus 0.17 times that by 30. 24.9. So the second point is met. Let's try if we do, should we try and do 60 instead of 30?
Yeah,
Each buy 30 bags?
Yeah, if we do like, if we just double our sample, so like every one we open 2. And then I think that would get us there.
Yeah, it'll barely make it. It'll be 10.2 if we do 60 bags of M&Ms.
I see.
So you're okay by, we're now going to analyze 30 bags of M&Ms each.
So we'll just go back and change all of our, like we both would choose 30 instead of 15.
Yeah, I think that's the only place that I put how many we're going to collect. So it'll be 60 total. 60 total. We're going to have, yeah. Okay, so we're each going to do 30 bags. I hope your family likes M&Ms. For a total of 60. And that will meet both requirements on that. Okay. Will your project involve human subjects? No, because we're doing M&Ms. Will you be conducting a survey? No, we're not using any type of questionnaire. Okay, if you answered yes, and he said to do one that does not require a survey because there's so much more work with it. If you're going to do a survey, you have to get it approved and everything else. So that's all we have to do as far as just writing that out and submitting that. So I'll try and type that up. But we're agreed that that's what we'll do. Is it'll end up being 60 from different states, and that just barely gives us the 10.5. So we can satisfy that one.
All right, that sounds good.
That I will email a file to you, and we'll submit it.
Okay. Sounds good.
So that part will be good. Let's see. Sorry, let me look in the back. When your instructor has his or her signature in step 15, you may register University's Human Subjects Board. No, sorry, that's okay. If you answered no to both questions, skip to step 19. Okay. I'm just going to cross those out so I know I don't have to do that. Okay, project approval. So yeah, that's just his project approval. So, all right. We have stuff to go over for the chapter 16 and 17?
I just have a question on 17, really.
Okay, I will try to see if I can help. I'm still trying to figure things out myself this week.
So I'll basically just tell you the question. I don't know. Do you have it with you already?
Which one? What are we looking at?
It's the homework quiz for lesson 17, and it's question 10.
Homework quiz for number 10.
Yeah. So basically, just like
Okay.
watching the video, he didn't, like, I don't know where he got the number, and then he divided it by 2.
Okay, he said that because the HA was 212 and they gave us the P to the right of Z was the 0.091, right?
So I didn't see that part, the 0.091.
Yeah, if you're looking at it, let me look at the actual question. I printed them up after I took the quiz, so I can always refer back to them and write down things that I need to look at. So which question was that again? It was
10.
So if you look at question number 10, if you look at it after it gives the Z-score, in parentheses it says under the standard normal density curve is 0.91.
Oh.
And that's where he got that number of, because he's saying that they gave you the test statistic of Z 1.334. And the area to the right of Z is that amount. And the area to the right of the Z is a one-tailed probability, right? Because that's what you're measuring as a probability. So if you had put in the Z-score of 1.334 and put, below, right now to the right of it, so it would be above that, then that was 0.091. And where this is a two-tailed test, you have to have, it's going to be an equal amount on the other side. So he just took the 0.091 and times it by 2.
Okay, so he times it by 2. I was just like, where did
Yeah,
he?
because,
okay.
Yeah, because you're only given the one tail, but it's going to be equal. So basically, you're given the probability of 1. You just times that probability by 2, and it will give it to you. You could go through the applet and
do all that.
Z-score and do the outsides, but yeah, that's how he did it. Is he said, hey, they already gave us the p-value of times it by 2.
Okay. Well, that was easier than I thought. Thanks.
Have any other questions on that?
No, that was it. It was like he just did it so fast. I was like, what? Where did he get all this information without having to leave the screen? So.
Yeah, and then I looked at like lesson 17 on number 5. Did you get all the way to the end of the quiz yet on the video?
For the homework quiz or for the group?
Sorry, the homework quiz.
I finished all of the homework quiz.
For 17, yeah, when you look at number 5, he's saying put it in the P as the number, the 71 over 785, because otherwise it can get you marked wrong.
So he did, what was it? Was it N over P hat, or was it the opposite?
And basically in determining the P hat, where's that equation? Yeah, you do the equation. The P hat for like number 5 was 71 over 785, and that's how you determined what the P score was. But if you had taken the 0.090 and put it under the P hat for the equation, you get the correct Z-score because they consider that rounding and they don't want it rounded. So in his spreadsheet, you'd put 71 slash rather than the actual P score, and then it's more accurate and you'll get the right Z-score.
That one was the one where it kind of messed up a little bit for number 6.
Yeah, that was the one that messed up number 6. So that's what he said. He says you're just going to have to remember to enter the formula for the P hat. So yeah, and so I did go through those. I got both the quizzes done. Now I'm just going to go through and do the homework and watch the videos for 17 because I haven't watched those yet, and just try to make sure I understand it because we have a test coming up in 2 weeks.
I know. Right before Thanksgiving too.
Thanksgiving. Yep.
So I was like looking. I was like, oh, maybe I won't have like a lot of stuff to do because I'm gonna travel and stuff. But then I was like, it looked pretty good. But then I saw that we had a test in 2 weeks, and I was like, I was so close to not having to worry about a lot.
Yep, and I have I'm hosting Thanksgiving dinner at my house. My son's coming back from college, and we have the missionaries coming.
That's neat.
And I think we invited one of their friends. So I'm like, oh crap, they don't give a Thanksgiving off.
Really? Yeah, my mom does Thanksgiving every year. Just a lot of people come over, and so I'm going to more of a smaller Thanksgiving. So I'm gonna see how it's gonna be. So.
Yeah, well, good luck, and